Okay, so in Notes 2.5, we're going to be putting all of the different types of equations that we've done this unit all together. So remember, I've told you that there's 3 different types of log equations. Some that have all log terms. If it has all log terms, you're trying to condense it into 1 log on the left side, 1 log on the right side. Once you've done that, you can set that m equal to n to find x. Okay? The other type is no log terms, which we did on Friday. No log terms means you have an exponential equation and you will isolate the base with the exponent, and then you'll take the log of both sides to solve for the variable. Okay? The third one is a combination of log terms. Okay? A combination of terms with logs and without. So I called it sum logs. Okay? If it's combination where you have some logs and some that are not, then you're going to rewrite it as exponential form to solve, which is around the world. And notice that it has some examples for you on each part. Okay? Alright, so we're going to solve each equation for x. So we first need to figure out what type of equation we have. Notice that we have a log, then we have another log, but notice on this right side here, that is not a log term, which means this is sum, or a combination. So that part C. If that is the case, you're trying to condense it into 1 log that equals the non-log. Okay? So I first need to get rid of that 2. So I'm going to divide by 2. Then I'm going to have log base 2 of x plus log base 2 of 5 equals 4. I want to condense that left side into 1 log. So notice we're adding and the bases are the same, so to condense we'll multiply. Log base 2 of x times 5, which would be 5x, equals 4. Once we have it to where the log term equals the non-log term, we're using around the world to change it to exponential form. So here's my base, so 2 to the 4th power will equal 5x. Now I need to work that out. So 2 to the 4th power, so 2 times 2 would give you 4, times 2 would give you 8, times 2 would give you 16, equals 5 over x, or 5x. Divide by 5, and then you can just leave it in fraction form, so x would equal 16 over 5. Remember, you need to check, just double check and make sure that that x, that m and m aren't negative, okay? And we've got a positive answer, so we don't really need to check for that here. Alright, let's look at number 2. Okay, so notice that we do not have a log in this equation. So this is no logs. If it's no logs, you want to isolate the base with the exponent. So circle it. We want to get that by itself. So I need to subtract 5 first. (17 minus 5), we get 12. Then I have to get rid of the 3 because I didn't circle that on the top. So I'm dividing by 3 because I want that base with the exponent by itself, and that will equal 4. This is what we did Friday. So now in order to solve the exponential equation, you'll need to take the common log of both sides. When I take the common log of both sides, remember that exponent becomes the coefficient in front. Make sure that you take the common log of the right side also, because whatever we do to one side, we have to do to the other. So from here, we're dividing by log of 5 on both sides. So we're using the calculator because we can plug in a common log on the calculator. We're taking the log of 4 divided by log of 5. And let's run it 3 decimal places, so that would be 0.861. And you can plug it back into the original and check it if you'd like to do that. Alright, so let's look at 3. Look and see what type of equation you have. Notice we have a log, we have a log, we have a log. All of them have logs. If they have all logs, remember you want the left side to be 1 log, the right side to be 1 log. So you're trying to condense it into 1 on one side, 1 on the other. So before I can condense, or my first step of condensing on the left side is to move that coefficient and make it an exponent. Then notice we're adding the 2 logs, which means to condense will multiply. So 2 cubed equals 8. So 8 times x, we're going to get 8x equals log of 24. So the left side we condensed to 1 log, the right side we already had 1 log. From here you can just drop the logs because we know that they're equal. So 8x would equal 24. So when you divide by 8, you get x equals 3. Okay, let's look at this last one. So notice we have a log, we have a log, we have a log, and log. They're all logs. So we're trying to do what we did on number 3. We want to condense the left side into 1, condense the right side into 1 also. Okay, so looking at the left side, we're adding those. So to condense, we'll multiply. Log base 2 of 3 times x, which would be 3x. So we're good on the left side. Now on the right side, several different ways of going about this. You could distribute that 2 to all of those to make them exponents, but that'll make large numbers there. So what I'm going to do is I'm just going to rewrite that 2 in front, and I'm going to condense inside the parentheses first. But like I said, you could go ahead and distribute that 2 if you wanted. Okay, so we're going to have log base 2 of 12. We're subtracting log base 2 of 4, which means we need to divide. But notice we're adding log base 2 of 3. So if we're adding, we should be multiplying. So whatever you're adding will go on top and you multiply. Whatever you're subtracting will go in the denominator. So I'm still not quite there yet. So I'm going to go ahead and work this out inside the parentheses. So 12 times 3, we get 36. So that would be 36 divided by 4. Which would be 9. So notice now we can get rid of that coefficient, make it an exponent. So we're going to end up with log base 2 of 3x equals log base 2 of 9 squared, which equals 81. From here, these 2 logs are equal. So now I can just drop the logs and set 3x equal to 81. So when you divide, x would equal 27. Okay, so 3 different types. All logs, some logs, or no logs. So you can refer back to that front page to determine what you need to do with each type of equation that you have.